Hey there, welcome to Hyperfacts. We're diving into one of the most mysterious and fascinating things in the universe: black holes. Imagine a place in space where gravity is so strong that nothing, not even light, can escape. That's what a black hole is. So how do black holes form? Well, it all starts with a star. Stars are like giant balls of gas, mostly hydrogen, that shine brightly in the sky. But stars don't live forever. When a really big star, much bigger than our sun, runs out of fuel, it can no longer hold itself up. The star collapses under its own weight, causing a huge explosion called a supernova. What's left behind is a tiny, incredibly dense core. If this core is heavy enough, it becomes a black hole. Now, let's talk about what happens around a black hole. The edge of a black hole is called the event horizon. It's like an invisible boundary. Once something crosses this line, it can't come back. Not even light. That's why black holes are, well, black. They don't let any light escape, making them invisible to us. But how do we know black holes exist if we can't see them? Scientists use special tools to observe the effects of black holes on nearby stars and gas. For example, if a star is orbiting something invisible and moving really fast, it might be orbiting a black hole. Also, when black holes pull in gas and dust, this material gets super hot and glows brightly, which we can see with telescopes. Black holes come in different sizes. There are small ones called stellar mass black holes, which are a few times heavier than our sun. Then there are supermassive black holes, which can be millions or even billions of times heavier than the sun. These giant black holes are usually found at the centers of galaxies, including our own Milky Way. One of the coolest things about black holes is how they warp space and time. Imagine space as a stretchy fabric. A black hole is like a heavy ball placed on this fabric, causing it to bend. This bending affects how objects move around the black hole and even how time flows. Near a black hole, time slows down compared to time far away from it. If you could visit a black hole, which you can't because it's super dangerous, you'd see time passing much slower than for your friends back on Earth. In 2019, scientists took the first ever picture of a black hole. They used a network of telescopes around the world to create a virtual Earth-sized telescope. This amazing image showed a bright ring of light surrounding a dark center, which is the shadow of the black hole. This black hole is in a galaxy called M87, about 55 million light-years away from us. Black holes are also famous for something called Hawking radiation, named after the famous scientist Stephen Hawking. He predicted that black holes can slowly lose energy and shrink over time. This is because of tiny particles popping in and out of existence at the event horizon. It's a really complicated idea, but it shows that black holes aren't completely black after all. Let's dive a bit deeper into the life cycle of a black hole. After a black hole forms, it can continue to grow by absorbing more matter from its surroundings. This process is called accretion. As matter falls into a black hole, it forms a spinning disk around it, known as an accretion disk. The material in this disk gets incredibly hot and emits X-rays, which we can detect with special telescopes. Another fascinating aspect of black holes is their role in galaxy formation. Scientists believe that supermassive black holes at the centers of galaxies play a crucial role in their evolution. These black holes can influence the formation of stars and the distribution of gas within the galaxy. In some cases, they can even trigger powerful jets of particles that shoot out into space at nearly the speed of light. Black holes also have a strange relationship with time. According to Einstein's theory of general relativity, the intense gravity of a black hole can warp both space and time. This means that time moves slower near a black hole compared to time far away from it. If you were to watch someone fall into a black hole, it would look like they were moving slower and slower as they approached the event horizon. Eventually, they would appear to freeze in time at the edge of the black hole. But what happens if you actually fall into a black hole? As you get closer to the event horizon, the gravitational pull becomes stronger and stronger. Eventually, the difference in gravity between your head and your feet would become so extreme that you would be stretched out like a piece of spaghetti. Scientists call this process spaghettification. It's a pretty gruesome fate, but it's all part of the strange and fascinating nature of black holes. Before we wrap up, let's remember that black holes are still full of mysteries. Scientists are always learning new things about them, and who knows what amazing discoveries we'll make in the future. If you enjoyed this video, don't forget to hit the like button and subscribe to Hyperfacts for more mind-blowing content. And if you have any questions or topics you'd like us to cover, leave a comment below. Thanks for watching, and see you next time.